This we are basically keeping this space open for those who are not enrolled in this boot camp. You might see something which you might feel as if you are just joining in between of something already going on, but that feeling is completely valid. Anyway, I'm going to, do some hands on. You can just keep watching me. Yeah, we are recording it, and I'll be also sharing the GitHub repo with you guys, so you can, just follow it, and you can clone it and, run that locally in your machine as well. So using Uniswap V4, we are going to create a limit order hook. So which means that if there is a pool, and a pool will have a pair, a token pair, say token 0, token 1, and you would like to take a profit when price hits at some point, then you will be placing a limit order, and when there is a match, the execution is going to happen. There will be some, assumptions which we'll be doing, and I will be walking you through what are the assumptions. Of course, the code which we are going to develop in today's session is not worth deploying for the production, so just giving you a disclaimer, but it will be a good exercise to know how you can build applications on top of this whole system. All right, so I'm just going to share my screen. I'm going to use Foundry. It's just a Solidity code which will be there, so there is nothing new that we're going to do. Of course, I'll try to also write down the test cases. However, I am not sure if we will be having time for writing the test cases, because we just have, like 1 hour. All right, so if you want to create a Foundry project, very easy, just say forge init. Sorry, I'm just going to create a directory, and I'm just going to name it as, say, take profit limit order hook. Okay, and let us initialize this using forge. Okay, let me just get my who you are. All right, so git wait. All right, just I'm going to one share. They're asking me to input something. I'm just going to do that. Okay, yeah, it was something which was related to git credentials. If you are already having it, then you probably will not have that issue. Anyway, so then you gonna just do forge in it, and okay, yeah, so I already have that. So the very next thing is we don't need all this files. I'm just going to go ahead and delete it. Counter. All right, as far as the installation goes, we would need V4 periphery from Uniswap. So I'm just gonna run forge install Uniswap /v4 periphery. Yeah, I mean, you're gonna get this warning, it's okay, but the reason you're getting this is you'll have to initialize, with git init, and if you don't do that, then this is what gonna happen. All right, so let me see. Okay, and now we also need to create the remappings. So there is a command called forge remappings, and you can just put it into remappings.txt, so you don't need to create one. Okay, so V4 periphery is being installed. It's a pretty big library. Mostly whatever libraries that we need to build this hook going to get installed here. And let me just run the remappings. All right, so this creates my remapping stuff. So I'm going to create a hook called take fits hook spdx. Okay, and I'm going to go with 8.0. All right, so before I start this, I just wanted to walk you through what we're doing exactly. All right, so let's just remove this guy. Okay, so yeah, as I said that we won't be able to finish up like everything in this session, but say for example, so limit order, say part one. Okay, so limit order based hook. How can we create a hook that like a simple order book? I'm pretty sure you know what an order book is. If you don't know what an order book is, there is a maker and taker. Maker is going to say that maker is Alice, for example. Alice wants to banana for one apple, or they want to buy, say, one. They want to buy 10 bananas for one apple, and so this is like Alice places an order, which is what we can say. Alice places an order to buy 10 bananas for one apple, and there is a taker called Bob who places an order to buy 10 sorry they want to buy one apple for 10 bananas, right? So here we can say that the order is matched, so we can settle, right? So what happens is Alice now has one apple, and Bob now has 10 bananas, right? So this is a simple order matching, right? So maker, taker, and you can settle, right? So this is known as this is a fully this has been fully fulfilled, and there is another type which is partially fulfilled. But I think the apple was the quantity of apple that the Bob wanted was same as what Alice wanted to sell for bananas. So there was an order matched happened, right? So order, we can say that order is fulfilled. Okay. And then there, if it would not have been the case where Alice would have been able to buy 10 apples, maybe if somebody wanted to sell, say, 5 bananas for half an apple, then we would have been called that it's partially fulfilled. So that's basically what it is. So coming back to what we are building is a simple order book which is on chain, and we are going to and integrating it with Uniswap, right? I'll be coming to all the questions. I'll be taking pauses like every brief minutes, and yeah. So what is that? It is a type of limit order uh, where you can sell an asset at a price higher than its current price, right? So for example, say if it is 3000 USDC, so what would be a take profit order, right? So take profit order would be something like, you can say that I want to sell 5 ETH, 5 ETH of mine when ETH uh, hits 3500 USDC, right? Now if you're doing any hook, or as far as this session goes, we are not going to go with ETH, like ETH versus ERC20 token. All we're gonna do is ERC20 to ERC20. Okay, so today what we are doing is we are building the key functionality which is required for placing limit orders. So you can place a limit order. What you can do, you can cancel order. We'll see. I mean, we'll go with the ideal route first. We will place it. Then when a user would like to swap, we're gonna call a hook function, and then a hook function is going to execute all the limit orders if it is going to get fulfilled. So placing order, cancel order, and then after you place an order, we will have to write an execution logic, right? So that's a core thing, core logic, executing those orders. Okay, all right. So ability to place an order, ability to cancel an order, and yeah. Uh, okay, so when you place an order, you will be getting some semi fungible token. So we can call it as we can say that mint ERC1155 token to show the position, right? And which means that after the order of this guy has been executed, the person is going to come to the book again and gonna mint and gonna redeem this 1155 token, right? Which means that we need a way for withdrawing the output token, right? So we've warned them that okay, you can now withdraw, maybe redeem the token that we get from executing order. Okay. So what's gonna happen is after and so after an order is placed, what happens is when the price is right, how do we actually execute it, right? Or can say that how do we do this as a part of a hook, right? And how do we know if the price is right? And that will help us to figuring out, and that is going to help us to figure out when to execute the order. Okay. And how do we send or let the user redeem their output tokens from their order? Okay. So we have a pool of let's say we have a pool of token A and B, and we're gonna call token A as token 0. So this is what the nomenclature you will see in Uniswap V4, and token B is what we're gonna call it as token 1, right? And the current tick of the pool is 500. If you want to know what the tick is, you can go and refer Uniswap V4 docs. But basically, ticks are going to use for getting the price, right? So the types of the take profit orders that can be placed, it could be sell some amount of A as A gets more valuable than B, or you want to sell some amount of B as B gets more valuable. So here what will happen is A is dropping in value. Okay. So say that in case 1, the tick is going to go even further beyond what it is right now, which is 500. And then we have got case 2. Case 2 is tick goes down below what is right now, right? So there can be only 2 cases. So when there is a change in tick value, when there is a change in value, then there will be swap gonna happen. So Alice placed an order to sell, say, some token A for B when tick is 600. Then what happens is Bob makes a swap on the pool by A for B, and that will increase the tick. Tick is the current price, increases the tick, and so new tick is 700, for example. Okay. So what will happen is so there are 14 hooks in Uniswap V4, we'll be implementing two hooks. One is after initialize and another is after swap, right? So because we are only interested when the price changes, so if you want to catch when the price change, you will have to implement the after swap hook, right? If you have experience writing the unit tests, you pretty much know about what hooks are: before each, after each, before all, after all, and stuff like that. So inside the after swap hook, we can see that tick just shifted from 500 to 700. So whenever we will be putting our execution logic, it will be it will come inside the after swap hook. So the tick just shifted from 500 to 700 due to whose swap, Bob's swap, right? And then we can check if there are any take profit order placed in yeah, so take profit order place in the opposite direction, which is in the range that tick just shifted, and we will find Alice order over there. And now we can, okay, so one thing here is there will be like a lot of orders being placed. So you might have questions on the gas cost and stuff like that. What if the transaction is going to be blocked by the block gas limit? We are just assuming that that's not going to happen, but it is, those scenarios are worth to consider. But right now we are just going with the very simple order book hook. So now we can execute the Alice order as requirements are met. So okay, so this is the mechanism design. And once you understand this, we're gonna just use we're just gonna use those in mind and come up with the hook. So we're gonna use base hook, and there will be also need of inheriting 115 here, because we need to give a proof uh, to the user that they have placed an order in this hook. Implements, sorry. Okay, now we need to get the base hook. So everything is available, as I said, in V4 periphery. If you can go to hook, so there is a base hook here. Just go import base hook from Uniswap. Sorry, it is V4 dash periphery src base hooks and src base hooks base hook dot sol. Okay, looks like a false call. All right, so we're gonna get this from same installation as well. So let's go to Open Zeppelin. I think the Open Zeppelin is installed here, V4 core. So Open Zeppelin / token. Okay, so looks good. Now they are complaining for inheriting certain things. Okay, so now we gonna go and call the things. Okay, so we have base hook, and then we have ERC1155. All right, so what does ERC1155 need? It needs a URI, so we're gonna get it from the deployment URI. Right, and from here we need this guy, manager. Okay, so the manager, we're gonna get it from V4 core. I pull V4 core core source interface. Okay, I pull manager V4 core interfaces. All right. Okay, so we also need to initialize the constructor of the base hook. So base hook needs a manager and I can just pass that here. Okay, and we also need to inherit this guy, call it as the hook permission. And okay, so you will be getting this from here. The hook is hooks. Okay. So hooks okay, so this is the hooks library. And we need to import as well. So hooks v4 or and libraries. Okay, and we'll have to written which hooks we're gonna use. And okay, so you're gonna go here. So these are the hooks which are available. So you will have to first of all, so this is what we call it as the pool configuration, right? Sorry, hook configuration, not the pool. I'm just going to some shortcuts here, and we're gonna let's initialize everything as false. So yeah, so we're gonna use after initialize. And yeah, so we need to know what is the price, and that can only be known after swap, right? And host dot permission typo. Okay, so this looks cool. So what we're gonna do is we need the hooks. So which hooks we need? We need this guy, and we need after swap this guy. All right, so and I'm just going to mark this as override. Okay, so we're not going to revert it. We will have to return the selector. This is what the convention of v4 is, that it expects you to return selector. Same goes for here, this dot. Okay, let's do this for now. Okay, so I'm going to go over the questions if you have any. Will the flash swap be available on new pools on Uniswap V4? Flash swap. I have no idea about it as of now. Yeah, no information for now. Screen share is not always okay. There are no major questions. All right. Okay, so what's happening here is so when you do after swap, this is the address of the caller who initiated the swap, right? Address of the caller who initiated swap, and we are just doing some sanity checks here. We don't want sender should not be this hook. Okay, so if sender equals the hook, which is address this, we're just gonna return. We don't want anything to take place. Okay, and yeah, so the logic to fulfill order starts here. However, we can only write we will be only able to fulfill if the user is able to place the order, right? So as per our mechanism design, just keep this in mind: placing the limit order, executing order, cancel order, and then redeem. This is all we need to implement, right? So yeah, so I would say, so these are now, all the functions we have here, they are all the external functions for the core hook. So this is now what actually we have to do. So we have got place order, external returns. Yeah, so placing the order, we need to give the user an ID of the order once it is placed. Then what we need to do next is we need to give a way for user to okay, user to cancel the order. Okay. And once the order has been fulfilled, we want a way for user to redeem the order. And then we will be having our core order execution functions going forward. All right, so the time which we have right now, I think we will be able to at least come up with a way to place the order. So when it comes to placing the order, you need to specify what is the pool ID. So we call it as the pool key here. Okay, and pool key is available in the V4 core. So we can put that from V4 or types. Okay, pool key, and what else we need for placing the order? We need to pass on the price at which we want to sell, right? So you can say int 24 pick sell at. Next, we need to pass on whether it is 0 for 1 or 1 for 0. Yeah, this is a concept for the contract in Uniswap V4. 0 for 1 can be, true or false, right? So whenever it is true, um, it means that you are selling token 0 for token 1, and if it's false, it's vice versa. You want to sell token 1 for token 0, right? What this means is, when 0 for 1 is true, um, the token 0 is going to get transferred to the pool contract, and token 1 will be transferred from pool to the user, right? And same and inverse um, for when 0 for 1 is false. So we need to specify this here, so that the hook is going to know which token should be, which token we need it in the pool, right? In the hook, sorry, and how much amount you would like to place an order for. So we need to get the tick, whichever is the lower usable tick. So we would need a helper function here to get function for getting lower usable tick. Private returns 24. So in order to get this, we need to know what is the tick value, and we need to know the tick spacing. So just imagine you have a number line, and on number line you have got some numbers which are spaced evenly. So this is what is known as tick spacing, in what implements, in what number of incremental value you want to keep on increasing, and then you got the tick. So it goes on either side of the number line, right? Yeah. So you want to get the intervals. What you need to do is, you can just say, you want to just divide tick by spacing, and you're gonna get the intervals. This is again going to be integer 24. There's a reason why we are using integer and not event, because ticks could be on either side. It could have a negative value as well. Tick spacing will be mostly positive, but just because of the casting restriction that we have in the solidity, we also make this as in 24. Yeah, there is no other good reason for that. So if tick is negative, which means if tick is less than 0, and if all the intervals are just fine, which means there is no remainder. So tick modulo tick spacing is not 0, then we're gonna just round. We're just going to round towards negative infinity, and then we're gonna return intervals time tick spacing. So that's gonna get us the lower usable tick, and can use this in place order. So tick is going to be get lower usable tick, and this is going to be the value at which we want to sell. So we would know that how much at what will be the value of tick when the tick at which we want to sell going to be the one which the user gave us. And every pool will have its tick spacing, so and get that from here. T dot tick spacing. Okay. um and yeah, once the user has a placed an order, we can mint a non-fungible token, is ERC 1155. So master dot sender. Yeah, we need to get the position ID as well. So it's just the token ID, and we're gonna use it for position ID. I mean, the position ID will be used for the token ID of ERC1155 that will be printed. So get position ID tick and 0. So we just want that it should be unique. So let's also get that here. That position ID needs you to pass the pool key, the tick value. This is a tick at which this is a tick that we calculated when the tick to sell is given, and what should be the direction of swap. And public returns. Yeah, I think this will be pure. We are just going to do a concatenation here using Kitschak 256 hash and ABI encoding. So you could return ABI dot encode, and we will just pass in the key ID, and the tick and direction. And once you have that, you're gonna perform Kitschak 256 hash, Kitschak 256, but you cannot return it as uint 256, so you can cast this to uint 6. Okay. Okay, let's go back to our place order function which we left. Right, so yeah, we need to have the position ID, the amount. So this will be the ID of the token, this will be the quantity. Data we don't want to pass because this is a semi-fungible token. So let's just make sure there are no syntax issues whatsoever, and override. Okay, so we also need to get the balance delta. Balance delta is a very interesting variable. It's not actually a variable, but it is a library which Uniswap is using for it is actually using it for storing the value of token 0 and token 1 just in the same variable. So it is of uint 256, which 128 bits are useful for token 0 and 128 bits are used for token 1. Yeah, it's a way to be efficient. So it's in libraries. Sorry, it's not in libraries. I think in types. Balance delta. Right, and click. So this is the right. So yeah, we're going to finish the place order stuff. So when you are placing the order, we need to keep track of all the claimed total supply for a given ID, right? Which means that we need a mapping for that will help us to get the total outstanding uh, tokens per given token ID, right? So we're gonna call it as position ID, and that will get us the claimable token. Right. So output claimable, claimable output, and we will also need the output claims supply, and we can call it as claims claim token supply. So what we're gonna do is we're gonna use claim to keep the track of how many tokens are there for this given position ID. So the way, I mean, if say for example, if the user is going to place another order with the same parameters, and this will get incremented by the input amount. Um, and so we need the address of the sell token. So the token which needs to be sold is something which user cannot pass because that is specific for the given pool. So we have got a library for in Uniswap, which we call it as the currency library, and that helps us to grab the address of token 0 and token 1. So the assumption which you have to make while you write this hook is the pool contract is already deployed on chain, and all you need is to just write a hook or the same. Okay, so currency. If it is 0 for 1, then the sell token is going to be token 0. Right? So we're gonna say that currency dot wrap dot currency 0. If it is false, then the sell token is going to be token 1, right? And once the user places an order, we need them to get their token they want to sell into this contract. So message dot sender into hook and the amount which they want to give us. And then we can return the tick value at which, if the tick if there is a price change which uses this tick, then the order will be executed. We are just 4 minutes above, but I'm just going to do a check. So yeah, we need to get ERC20. So I'm going to get ERC20 here. Okay. One more thing which we are missing is in after initialize. So we need to keep track of all the ticks here, and this the key. When the pool was initialized, what was the tick is what we needed here, and that's the value. And last tick is a mapping which we need, and that is basically between pool ID pool ID. Okay. Different types. Right. So this is for the place order. In the next session, we will be covering the rest of the functions.